So good evening everyone. Today we will basically going to solve this geometry problem in which it is being given to us that we are basically having a semicircle, or you can simply say a quarter circle in which we need to find the value of x. Okay, we are given some information, and with the help of these given information we need to find the value of x which is being given in this geometrical diagram. So this question is actually very simple if you know a theorem, but if you don't know that theorem, then this question can become a complicated issue for you. But first of all, let us start very simple. In this case, uh, we will basically going to redraw this diagram in a larger extent in order to fully understand the conceptual analysis which is being given for this question. Let us have this semicircle in a big scale. Let us suppose that this is our semicircle, and this point is A, this point is D, and this is a right angle, and this point is C, this point is B, this point is O, and this is 7, and this is 24. We need to figure out what is the length of CD. As we all know that this is a quarter circle, then the dimension of AO will be equal to the dimension of OB because both of them are radius. So it will eventually going to be the same. Moving ahead. So first what we can do is we can draw a hypotenuse here, and since 7 and 24 can produce a hypotenuse AC which will going to be 7 square plus 24 square, that will simply going to be 25. Unit is not given to us, so we will be not going to write the unit. We will only going to write the dimension, like AD is 24, DC is 7. So in the basis of this, by using the applications of Pythagorean theorem, we have got that the value of AC will basically going to be 25. This is also a right angle because it is a quarter circle. So now this is 25, and this is x. So the value of AO will going to become square root of 25 whole square minus x square, and this is our radius for now. So this we need to take into our consideration here. So these are this is a triangle obviously. So, and let us assume that this angle here, this one, this is theta. Okay, so let us suppose that this angle is theta. So if we suppose that this angle is theta, then with the respect of this we can say that CD is actually 25 of sine theta, and the value of AO will going to be 25 of cos theta. This will basically going to be its value. So now we know the dimensions of all the four sides of this quadrilateral. Now what we can do here is this is 25 cos theta, this is 25 sine theta, and this is one area which we need to calculate in this case. So there's one theorem which we can use straightforwardly and get the answer. If we connect D and O, as we all know that OB is equal to OA is equal to OD, because all of these three lengths are the radius of this quarter circle or the radius of the circle. So OD will also going to have the length of 25 cos theta because it is the radius, and the radius AO is also having the length of 25 cos theta. Now what Ptolemy's theorem states that, as we all know that this quadrilateral ADCO is a cyclic quadrilateral. How it is a cyclic quadrilateral? Because we can see that in this quadrilateral the opposite angles are making the sum of 180 degrees. Okay, so the opposite angles that we can simply see here are basically making the angles sum of 180 degrees. So this is actually a cyclic quadrilateral, and a cyclic quadrilateral is actually that quadrilateral which can perfectly be inscribed in a circle. So if we try to draw a circle, in this case like this, so it will perfectly going to blend in a circle. So then we can basically going to say that the quadrilateral ADCO is a cyclic quadrilateral, and in any cyclic quadrilateral we can apply what we call as the Ptolemy's theorem. Now the derivation of the Ptolemy's theorem is actually very simple, and it is precisely being based on the concept of basic proportionality expression, which is a concept of similarity of triangles. But right now we are not going into that details, that what we will basically going to have into its proof. We will straightforwardly going to apply the Ptolemy's theorem, and Ptolemy's theorem simply says that the sum of the product of the two opposite sides of a cyclic quadrilateral is equal to the product of its diagonals. That simply means that AO multiplied with its opposite side DC plus AD multiplied with its opposite sides OC will be equal to the multiplication of its diagonals, or the multiplication of the cyclic quadrilateral diagonals. That will going to become DO into AC. So the value of AO is 25 cos theta, the value of DC is 7, plus the value of AD is 24, the value of OC is 25 sin theta. The value of DO is 25 cos theta, and the value of AC is 25. So we can simply see that 25 is everywhere, so we can cancel this 25, 25 and 25. Then we will basically going to have 7 cos theta plus 24 sin theta is equal to 25 cos theta. Oh, now it is a very good expression. So 24 sin theta is equal to 24, 23, 22, 21, 20, 19, 18. So 18 cos theta. So with respect to this, what we can get is that the expression for tan theta, actually what do we want? We want the value of CO. Okay, we want the value of CO. हम लोगों को CO की value चाहिए, तो CO हमारा इस केस में है 25 sin theta. So we need the value of this sin theta. So now what we will basically going to do, first we can make it like 4 sin theta is equals to 3 cos theta. That will basically going to become 16 sin square theta is equals to 9 times of cos square theta, that we can make it as 1 minus sin square theta. So that will basically going to become 25 sin square theta, which is equal to 9. So as we need the positive value of sin theta in this case, that will basically going to become 3 by 5. So then the value of CO will basically going to be 25 into 3 by 5. So the value of this will basically going to be 15 units. Hence the value of CO is 15 units, and that is the solution for this question. This question was actually very easy if you know this theorem, and if you don't know this theorem, then this question will going to be a blunder for you. But yes, there are methods to solve this question if you don't know Ptolemy's theorem. But I will basically going to try to make a separate video on it, because I know one method through which we can solve this question, and it only requires basic trigonometrical knowledge, but it will going to be bigger, so I will going to add it up in a separate video. So thanks for now, and through this video you also get to know about a new theorem regarding cyclic quadrilateral, and this theorem will especially going to be very useful for you if you are preparing for Olympiads or especially JEE Advanced, because they actually use tricks in order to solve such questions. Thank you for watching this video and subscribe if you have not done so.